Download this code from codegive.com, link in the description below. Don't forget this API security measure, input validation, with code examples. API security is a multifaceted discipline, requiring a layered approach to protect your valuable data and backend systems. While often overshadowed by concerns like authentication, authorization, and rate limiting, input validation is a fundamental and non-negotiable security measure that can significantly reduce your API's attack surface. Ignoring input validation leaves your API vulnerable to a wide range of attacks, including injection attacks, buffer overflows, and denial of service attacks. This tutorial will delve into the importance of input validation, explore different techniques, and provide code examples across various programming languages to help you implement it effectively. What is input validation? Input validation is the process of ensuring that data received by your API conforms to expected and acceptable patterns, formats, lengths, and types. It's essentially a set of rules and checks that are applied to any data coming into your API before it's processed or stored. Why is input validation so crucial? Prevent injection attacks. Injection attacks, such as SQL injection and command injection, exploit vulnerabilities where untrusted data is directly incorporated into commands or queries executed by your application. Input validation can prevent these attacks by sanitizing or rejecting malicious input that attempts to manipulate these commands. Prevent cross-site scripting. XSS attacks occur when malicious scripts are injected into web pages viewed by other users. Input validation can help prevent XSS by encoding or escaping user-supplied input before it's displayed in a web page. Prevent buffer overflows. Buffer overflows happen when a program writes data beyond the boundaries of a designated buffer, potentially overwriting critical program data or executing arbitrary code. Input validation can prevent buffer overflows by limiting the size of the data that's allowed to be written to a buffer. Enforce data integrity. Input validation ensures that data stored in your database is consistent, accurate, and conforms to predefined data types and constraints. This prevents data corruption and maintains the reliability of your application. Prevent denial of service, DOS, attacks. Attackers can exploit vulnerabilities related to input processing to overwhelm your API with malformed or excessive requests, leading to a denial of service. Input validation can mitigate DOS attacks by rejecting invalid requests early in the process. Reduce errors and improve reliability. Input validation helps catch errors and inconsistencies early on, preventing them from propagating through your system and causing unexpected behavior. Types of input validation techniques. 1. Data type validation. Verify that the input data matches the expected data type. For example, if you expect an integer, ensure the input is indeed an integer. 2. Range validation. Check that the input value falls within an acceptable range. For instance, an age should be a positive number within a reasonable upper limit. 3. Length validation. Ensure the input string or array doesn't exceed the maximum allowed length or fall below the minimum required length. 4. Format validation. Verify that the input adheres to a specific format, such as email addresses, phone numbers, or dates. Regular expressions are often used for format validation. 5. Character validation. Restrict the characters allowed in the input string. For example, you might allow only alphanumeric characters for usernames. 6. Whitelisting versus blacklisting. Whitelisting, allow listing explicitly define what is allowed. This is generally the preferred approach because it's more secure and less prone to bypasses. You only accept input that matches your predefined criteria. Blacklisting, deny listing define what is not allowed. This approach is less secure because attackers can often find ways to bypass the blacklist. 7. Sanitization * modify the input data to make it safe for processing. This might involve encoding special characters, removing unwanted characters, or truncating strings. Sanitization should be used carefully, as it can sometimes alter the intended meaning of the data. 8. Encoding/escaping * convert characters that have special meaning in a particular context, example HTML, SQL, into their equivalent encoded or escaped forms. This prevents these characters from being interpreted as commands or code. Where to perform input validation *. Input validation should be performed at multiple points in your application. Client-side validation, browser provides immediate feedback to the user and reduces the load on the server. However, it should never be relied upon as the sole source of validation, as it can easily be bypassed. Server-side validation, API the most important location for input validation. This is where you ensure that all data received by your API is valid and safe before it's processed or stored. Database validation databases often provide constraints that can be used to enforce data integrity. These constraints should be used in conjunction with server-side validation, not as a replacement. Code examples, with explanations. Here are examples of input validation in different programming languages. 1. Python, using Flask. Explanation ***. Rematch **. We use regular expressions for format validation of email and username. This allows us to enforce specific patterns. The $AZAZ0-9_+ $regex ensures the username only contains alphanumeric characters and underscores. The email regex is a common pattern for validating email addresses. *len, we check the length of the username and password to ensure they meet minimum and maximum length requirements. If not data and data.get, robust handling of missing data or invalid JSON payloads. Data.get is preferred over data username because it handles the case where the key username is missing, returning none instead of raising a key error. Whitelisting the username validation uses a whitelist approach by explicitly specifying the allowed characters. Error handling the code returns specific error messages and HTTP status codes, 400 bad request, to provide clear feedback to the client. 2. JavaScript, Node.js with Express. Explanation Express validator This middleware provides a declarative and powerful way to define validation rules. Body this function specifies the request body parameter to validate. Is string, is length, is float, is int. These are validator functions that check the data type and constraints. Trim, removes leading and trailing witty space. Escape, escapes HTML characters to prevent XSS attacks. Validation result, this function checks for any validation errors. Error handling if validation fails, the code returns a 400 bad request status code with an array of error messages. Optional, indicates that the description field is not required. 3. Java, using Spring Boot. Explanation at validated and at valid these annotations enable validation of the request body. At validated is at the class level and enables the bean validation feature of Spring, while at valid is used to trigger validation on a specific argument. Bean validation annotations, JSR 303/380. At not blank, ensures the field is not null or empty. Asterisk at size, specifies the minimum and maximum size of the string. Asterisk at email, validates that the field is a valid email address. Asterisk at pattern, validates the field against a regular expression. Asterisk user registration request asterisk this class represents the structure of the expected request body. The validation annotations are placed directly on the fields of this class. Asterisk error handling asterisk Spring Boot automatically handles validation errors and returns a 400 bad request status code with a detailed error message. You can customize the error handling using @exception handler methods. Asterisk whitelisting asterisk the @pattern annotation enforces a whitelist approach for the username by specifying the allowed characters. 4. C.NET. Explanation asterisk. Asterisk data annotations asterisk C provides a powerful attribute-based validation system using data annotations. Asterisk required asterisk ensures the field is not null or empty. Asterisk string length asterisk specifies the maximum and minimum length of the string. Asterisk email address asterisk validates that the field is a valid email address. Asterisk regular expression asterisk validates the field against a regular expression. Asterisk model state. Is valid asterisk this property checks if all validation rules have passed. Asterisk error handling asterisk if validation fails, the code returns a 400 bad request status code with the model state object, which contains the validation errors. Asterisk from body asterisk indicates that the user registration request object should be populated from the request body. Best practices for input validation asterisk. Asterisk validate everything asterisk validate all input data, including request parameters, headers, cookies, and file uploads. Asterisk use a framework/library asterisk leverage existing validation frameworks and libraries whenever possible. They provide pre-built validators and simplify the validation process. Asterisk centralize validation logic asterisk avoid scattering validation logic throughout your code base. Create reusable validation functions or classes to maintain consistency and reduce code duplication. Asterisk log invalid inputs asterisk log invalid input data to help identify potential attacks and improve your validation rules. Asterisk escape outputs asterisk always escape or encode output data before displaying it in a web page or returning it in an API response to prevent XSS attacks. Asterisk regularly review and update validation rules asterisk as your application evolves, your validation rules may need to be updated to reflect changes in data formats and security requirements. Asterisk don't trust client-side validation asterisk always perform server-side validation, even if you've implemented client-side validation. Asterisk assume all input is malicious asterisk this is a fundamental security principle. Approach every piece of incoming data with suspicion. Asterisk use strong password policies asterisk enforce strong password policies, including minimum length, character requirements, and password complexity. Asterisk consider a web application firewall. WAF A WAF can provide an additional layer of security by filtering malicious traffic and blocking common attacks before they reach your API. Conclusion asterisk. Input validation is a critical API security measure that helps protect your application from a wide range of attacks. By implementing comprehensive input validation techniques and following best practices, you can significantly reduce your API's attack surface and ensure the security and reliability of your system. Don't underestimate the importance of this foundational security control. It's a small investment that can yield a significant return in terms of reduced risk and improved application stability. Remember to choose a whitelist approach when possible and to combine validation with other security measures for a comprehensive security strategy.